to our classrooms. All right, here we go. So remember, electrons need to live somewhere, okay? And there's different ways of doing electron configurations. The most conceptual and easiest to follow is this expanded filling diagrams. I'm going to show you the compact filling. We're going to have to know this one, and don't worry about noble gas configuration. Again, if you know where the element is on the periodic table, you're going to know where its last electron is located, what energy level, what block it's in, what sublevel, and have to remember the rules we learned yesterday. Right? So I'm going to start out with an example, and then we'll do one more example, and then I'll set you loose on your own example. So this is sodium. It's element 11. Okay, so I'm going to escape out of here. No, I'm not. Yes, I am. I'm going to go right to the, I did some doodling first period. Maybe I should doodle one more time, and then I'll do some others with you. So the expanded filling diagram, again, makes sense because low energy is at the bottom. The lowest energy electrons are going to be closest to the nucleus. The highest energy electrons are going to be farthest away from the nucleus. They have the biggest clouds. They have the most energy to escape that positive. And so if we pick sodium, and remember, this is another thing you need to review. Sodium is Na. That's from its Greek name, natron or natrium. It's not S, that's sulfur. So sodium is on the periodic table right here. Okay, so its atomic number 11 tells us how many electrons it has. It's on the 1, 2, 3, third energy level, and it's in what we call the S block. Okay, so that information gets us off to a good start. Okay, first thing you need to know, 11 protons means it has 11 electrons when it's neutral. It's on the third period, and it's in the S block. Remember, the periods on the periodic table correspond to energy levels, which correspond to the principal quantum number, and the block corresponds to the sublevel, which is the second quantum number. So I know that, oh, and one more thing, it's in the first column of the S block. This is the second column of the S block. So that means sodium's last electron is going to go into the 3s orbital, and there's one electron there. When we do these filling diagrams, you can start with the last one. It's okay. Okay, so I know that's where I'm going to end. Because of its position on the periodic table, I can figure that out. And then remember, off-bow tells us all these other orbitals have to be full. We have to have that foundation before we put one in the top. So each of these little boxes is an orbital, and we use these little slash marks for electrons. Okay, 1, 2, the 1s is full. Remember, s's can only have 2 electrons. 1, 2, the 2s is full. The p's, we're going to fill them half at a time, so all their spins are maximized. Remember, that's Ohm's rule. And then we're going to double them up. That's just a good habit to be in, because sometimes the p's don't get filled up. And you want to make sure that you keep those seats on the bus spread out. All right, so the next thing we're going to do is going to go, okay, first layer, the 1s has 2 electrons. Second layer The 2s has 2 electrons and the 2p has 6. Last electron, 3s1. So this, my dears, is the electron configuration for sodium. Remember, we don't say squared. This is just a count of electrons. Let's see the one here. That's right there. So 2 and 2 and 6 and 1 makes 11. We're good to go. It's 1s2, 2s2, 2p6, 3s1. That's the electron configuration of sodium. All right. Let's see. Remember, things get a little weird on the on the 4th energy level. So let's go back and look at the periodic table. First one has just 2 elements, hydrogen and helium. Okay, remember the first energy level only has the 1s. Second energy level, it's another sub-level, 2s and 2p. Third energy level gets 3s, 3p, and 3d. Now you should be going, what? Why is the 3d on the 4th line? Okay, that's because the 4s only has to hold 2 electrons. Boom, boom. The 3d has to hold 10. All the electrons are negative. They all repel each other. And so it's a little tiny bit more energy is needed to hold these 10 electrons together versus just 2. Okay? The 4s is still higher than the 3s and bigger than the 2s and bigger than the 1s, like our little nesting dolls. The p's are correctly oriented. It's just this weird little glitch on the d's, which accounts for these transition metals, there's 10 transition metals per line. This is the 3D, the 4D, the 5D, the 6D. We will never go past, I think I can say confidently, we will not go past the 4th energy level. Okay, so not have to worry past 3D. All right, questions. There must be some. Anybody?
I didn't really get the electron configuration part.
Okay, oh, the letters and numbers?
Oh, yeah.
At the end, yeah. Okay, I think after we do another example, it might help. So let's just switch to that. So thank you, Anita. When you go to your classwork, I don't know how you split your screen. There was a little trick. I don't even remember what it is now that Mr. Pelfrey shared early on. You can also just make 2 windows. You can also drag it off by itself, right? You guys know how to do that? So I don't know how you're going to do this so you can see what I'm doing and do it yourself, but I want you to do these examples also. So I know I have a lot of stuff up here. Let me get rid of some of this. Oops, I don't want to do that one. I already showed you the journal. Okay, so let's go back here. Little feeder caps. So this should be in your feed. This is my version. You have your own, okay? When you're in Google Slides, they're really tiny, so it's super difficult. So if you click on the magnifying glass and click at least once, and then turn the magnifying glass off, you should be able to see it a little bit easier. Again, the first slide on this slide deck is a periodic table and the blocks just for your reference. So you can look at that. Okay. And then slide number 2 is the diagram with some spaces to fill in. So we're going to do a sample. Let's do nitrogen. Okay, so element goes here. Remember the symbol for nitrogen is N. Nitrogen is, I don't know if this is going to show. Oh, it is. How about that? Nitrogen's right here. Okay. But for some reason it's not giving me a color. It's all right. Nitrogen's right here, and nitrogen is right next door to carbon, and it is element 7. So when you go to your slide, if it's got an atomic number of 7, it also has 7 electrons. Okay. So far, so good. So the next thing we're going to look at is what line is it on, and nitrogen is on the second line of the periodic table. Oh, I'm teaching. You wouldn't mind. Sorry, dear. My dad's calling. Sorry. This is so crazy this time of year. Okay, so here we go. Where was I? I'm sorry. 7. So it's on the second energy level, and nitrogen's in the P block. And the other information you need to know about nitrogen is what column it's in. So it's in the 1, 2, 3rd block. Excuse me, 3rd column of the P block. So I know that nitrogen is going to have its last electron in the 2p, and then remember how to do superscripts or exponents. You do, I think on Chromebooks it's control period. On my MacBook it's command period, and there'll be 3 there. Okay, remember to do control or command period again to get out of the superscripts. All right, so now we know we need to get to 7 electrons, and the last one's going to go in the 2p. So I made X's for representing 1, 2 electrons, and I made single slashes in blue. So it's going to be, remember, seats on the bus, 1 electron at a time into the 2p. And let's do this if it makes it faster. So drag it all the way. So I made these little drag and drop slash lines. Okay, so that's 3 electrons. And remember, Aufbau says these lower orbitals have to be full. We have to fill these before we add. So I'm going to drag over this 1, 2, and another one. So when you count now, you should have the right number of slashes as electrons. Okay, 1, 2, 3, 4, 5, 6, 7. And we do. Okay, so we're ready to go for nitrogen. Sorry about pop-up. So do the same thing. So obviously these expanded diagrams are super big. I hope you're following along and dragging them along like I'm doing, because you need to. Okay, and then I'm going to cheat and I'm going to copy and paste these. Let's see if that works any better. Copy, paste, and then, no, that would be too far apart, but the idea is there. And then to answer Anita's question, how do we do the next part? Isn't it? Okay, so the last part is like this. So the 1s orbital has 2 electrons in it. So we do command period and then put a 2. If we command period space, 2s also has 2. And then the last one, the 2p, has 3. So this notation at the top, these exponents, for lack of a better word, they're not exponents. This is read 1s2, 2s2, 2p3. 2 and 2 and 3 make 7. These are just counting how many electrons that atom has. Okay. Questions? Anybody? All right, I'm going to try one. I'm going to ask, so I'm going to pick on some people right now, okay? So let's try one together. Let's do potassium, okay? So first thing, so we're going to go to the next slide, sorry. Next slide. Remember, potassium is not P. That's phosphorus. Potassium is K. Okay. So, meeny, meeny, miny, mo. Boom. Brooke, what is the number of protons for potassium? The Brooks here today. Called on 3 people.
Is it 19?
It is. Good job. Perfect. So we're going to go back to my slide. Okay. And so potassium has 19 protons. Oh, and the boxes aren't quite big enough for 2 numbers. Sorry about that. And that means it also has 19 electrons. Pretty good with that, I hope. Okay. The next thing we need to know is what period potassium lives on. So, Kyle, what line on the periodic table, what period is potassium on? There he is. Kyle, you there, bud? You can type it in the chat.
Is it the 4th line?
Is it the 4th line, he asks, and it's the 1, 2, 3, 4. Good job. You are correct. Thank you. So 4th quantum number, 4th principal quantum number. And last question of the day for now. Caden, what block is potassium?
The S block.
Absolutely correct. And since it's in the first column in the S block, I know that, oops, I lost my place, there we go. I know that its last electron is going to load into the 4s, and there's only going to be one of them. So right off the bat, I'm going to start out by moving an electron over to the 4s. And I'm going to remember, make sure you do this on yours too, and I'm going to remember then that all these other layers have to be filled up. The off-valve principle. You've got to build your foundation, get those closer to the nucleus filled in. Okay, and I'm not going to take the time to move all the X's, but I'm going to make you do that, and I'm going to give you one example. So again, we know that the one, well, maybe I'll move a couple of them. The 1s is full, the 2s is full, the 2p's are full, and it's just simply a body count. How crude is that? Of how many there are. Okay, so I can paste another one, and oops, maybe I can move it up. Oh, I tweaked it. Okay, I don't know what I did. So you get all of these would be filled in. I'm guessing it's probably, you guys have a better, I can't drag and drop for some reason. You guys have a trick for that? I doesn't want to drag and drop. But I can arrow over. So that's what I'm doing ever so slowly. I said I wasn't going to do this, and here I am. Okay. And again, these, I could probably do that. Let's see what happens. Boop. Yay. So there you go. There's a little speedy our way. Do one of them and they'll all fill in. All right. The 1s is full. The 2s is full. The 2p's are full. The 3s's are full. The 3p's are full. What does that mean on configuration? 1s has 2, because all s's can only have 2 electrons. 2s so has 2. The 2 3p has 6. The 3s has 2. And the 3p has 2. And finally, that last lone electron. Why did it go there? Oh, Christmas tree. The last little electron goes into the 4s, and there's only one of them, all by its lonesome, far, far away from the nucleus. And we'll talk more about what that means when we get back in January. All right, questions right now. Anybody? Anita, did that help?
Yeah, I got somewhere with it.
Okay. All right.
Thank you.
So you're welcome. And so the last one I'd like you to do, so that we did 2 examples together, so those should be filled in. And then the last one I'd like you to do on your own and submit this by tomorrow, so you have time. You can ask me in the office hours. Why don't you guys do sulfur? Okay, so you get to do sulfur. And someone had a question. So everything is an X except, well, it depends, Abby. That's a good question. So the X is, remember, it's /1 electron /2 electrons. So you can only have 2 electrons in an orbital. Okay, so if wherever the last one lives, it could be doubled up. Okay, it's possible to be doubled up, like calcium would end with an X, if you will. Okay, so it's just how many electrons it has. Let me go back and look at that too and count with you guys one more time. Okay, so again, oops. Calcium. 1, 2, full. 1, 2, full. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. So 2 and 2 is 4, and 6 is 10, and 2 is 12, and 6 is 18, and now one more. So if it's an odd element, odd numbered element, yes, it'll end with a slash. If it's an even numbered, I have to be careful. There are some that won't end with it varies. It's just counting your electrons. We choose what element to do for the last ones. No, so don't do 5 and 6. Just do sulfur. Sorry, I was ambitious. I made extra slides and you don't need it. Just do sulfur, and that's on, I believe, slide 4. Yeah. Don't worry about 5 and 6. Okay. I guess forget about them. Anybody else? Great. Well, if there's no other questions, then we're going to go